Finding groundwater in humanitarian crises. Of all the natural resources that are explored for on this planet, none is more highly sought after with as little technical expertise and professionalism than groundwater. Water well drilling success rates of less than 1 in 4 and even less than 1 in 10 are very common in many humanitarian relief efforts. Yet nowhere is this more true than in refugee situations where, most commonly, refugees are fleeing one arid or semi-arid country like Syria, Afghanistan, or Somalia and finding refuge in a camp in the marginal living zones of other semi-arid or arid countries like Jordan, Pakistan, or Kenya, where the Kakuma refugee camp in this photo is located. Water resource exploration in humanitarian crises is usually supervised by a logistics officer or public health official, or at best a water and sanitation generalist. The challenging and crucial task of finding groundwater is rarely undertaken by trained geophysicists or hydrogeologists with appropriate equipment. In this electrical resistivity tomography section, or ERT as we call it, we can see a shallow, very high-yielding well of excellent water quality penetrating the geophysically imaged sand channel contoured in pink. Previous wells penetrated much deeper weathered volcanics that produce lower yields with fluorosis producing concentrations of dissolved fluoride. Today, there are 27 million refugees in the world who have fled across their own borders, but there are an additional 46 million internally displaced persons, IDPs, who have fled their homes and villages within the borders of their own countries. The 25-year civil war in northern Uganda and Acholaland resulted in 2 million Ugandans being placed in internment camps, with people only beginning to return to their homes and villages in 2006 as the war began to run down. The villagers need to develop and redevelop water supplies in their villages. In this geological section, the CRT section, you can see that an igneous intrusion, the vertical feature contoured in red, acts as an underground dam with water that has saturated conditions only to the left of the intrusion. Without geophysics, one is simply left guessing where to drill. Climate change, drought, and a consequent lack of water have created incendiary conditions for civil war in some countries like Yemen and Syria. This seismic reflection section collected for oil and gas exploration, collected in the Hadramaut province in Yemen, you can see how by simply examining existing oil exploration seismic data, we can confidently site a water well in an area where numerous international humanitarian efforts had previously drilled many deep, dry holes, some as deep as 700 meters or more. My first drilled well, based on previously collected oil and gas seismic data, produced greater than 1,000 gallons per minute at a depth of less than 100 meters. Of course, natural disasters can damage aquifers, such as saltwater intrusion caused by the 2004 Boxing Day Indian Ocean earthquake and tsunami. Many tens of aid organizations drilled saline wells in their attempts to reestablish water supplies. In fact, the German government used airborne electrical methods to map the full extent of saltwater impact, contoured here southeast of Banda Aceh, the capital, but unfortunately, very few aid organizations lacked even the basic geophysical and hydrogeological knowledge to make full use of the data. More than 150 billion US dollars are spent annually on international development, and more than 30 billion of this are spent on water and sanitation. But after decades of similar spending, barefoot children with 20-liter jerry cans on their heads, walking kilometers each day to gather poor quality water, and scenes like this are in fact still the norm. It's about time that some rigorous geoscientific exploration approaches become routine in the effort to provide water in humanitarian crises.